Good morning. I will show you today how to do a formula questions in Canvas. I will use the old quiz. So for this example, I will show you a roller coaster problem. So before I enter the formula questions in Canvas, I will show you the problems on that side. So this is a roller coaster. A roller coaster is made of hills and loops. Something to know about roller coaster is that they are free to ride. So there's some energy up to the top hill. So there you will have usually a motor that help you climb the first tallest hill. And when we arrive at point A, the roller coaster, the wagon are released from rest. Usually your release is almost zero there. It's released from rest and now it's free to ride down, get to the loop. So what does that mean? It means that there's no external energy. The only energy that is there, if we consider that there is no frictions, no drag, it will be the potential energy from the altitude of the wagon and the weight, and the potential energy from the velocity. So in other words, when the altitude of the wagon is high, when it's very high, the velocity will be low, and when the wagon will be low, the velocity will be high, etc. So the question is, if we release the roller coaster at the point A, the altitude of the roller coaster at A is maybe 30 meters, and the first loop, the altitude is maybe 20 meters. The question is, what is the velocity VB? So what is in blue? Let me remove my. So everything that is in blue is given, is data that are given, and what is in red is the value that I'm looking for. So how do we solve that? We could give to the students, all of them, they have HA equal 30 meters, HB equal 20 meters, or we can give them randomized numbers. And VB, we need to find VB in terms of HA and HB and VA. VA is 0, but in terms of those three. So how do we solve that? Very fast, just to show you the steps. We use the theorem of conservation of energy that tells us that the velocity, the kinetic energy, TA, from the velocity plus the potential energy at A will be equal to the kinetic energy at B plus the potential energy at B. In other words, when we replace each term by the formula, the kinetic energy is 1/2 of mv squared, and the potential energy is the weight times the altitude, so mg times the altitude. The initial velocity is 0, VA equals 0, so we can remove this term. So that's how we get to that step. After that, we have the mass in every term, so we can divide by the mass. From that point to that point, I just multiply by 2 everything. So we have 2GHA equal VB squared plus 2GHB. Remember that we tried to find VB in terms of HA and HB. Multiply by 2, move that term to the left, factorize by 2G, and to remove the square roots, to remove the power 2, we take the square roots on both sides. So at the end, we have the formula VB in terms of HA and HB. VB equals the square roots of 2G times HA minus HB. G is given, and in international units, it will be 9.81 meter per second square. Always the same, never change on Earth. So now, how do I take this problem, put it in Canvas, and enter this formula? So all the students have different numbers, HA and HB, but the answers that we are waiting for will be their own VB. So I am on Canvas on the left. It's a new questions. So you will select, instead of multi-choice, you will select formula questions. Okay, I will copy paste this text. Oops. Yep. So we have it there. I will paste the picture. Oops. Here we go. And that's the questions. And here, let me make it a bit bigger. So that's the formula that we want to enter. Oops. Let's remove this. So they are happy. So here, what is providing is the altitude HA and the altitude HB. So what you will do is that you will add, after HA, equal, I need to remove the points, and bracket, and write HA, and let's put the units meter. So here, let me put it in, I don't know if you can see, I add the bracket, equal bracket HA, meter, and after the HB, I will go equal bracket HB, and meter. Okay, I will remove the point there. So now I have HA and HB here that are two parameters. Let's put 30 to 50, and this one, let's say, could be 10 to 20. And my formula should be the square root of 2g times HA minus HB. Make sure that you write your parameters with the same way that you define them. So here, I will. You don't need to put the equal in front, as Excel is just square root SQRT of 2 times, so g is 9.81. Oops, times, so I'm typing there. Oops. HA minus HB. I close the parentheses. Save, and that will give us a value of 21 meter per second if HA equal 42 and HB equal 19 meters. You can be a little bit more precise and use one more decimals or more. After that, you can generate 24 different random numbers. Always put a margin, error margin, because students sometimes run too early. And you click on, oops, let's see, it's just working, and you click on generate. I click on recompute because sometimes otherwise it just always gets stuck on those two values. So now on the bottom, we have 24 different sets of parameters and their value. And you click update the questions. And that's it. That's it, it's done. I will show you now what this looks like in the quiz. Oops. So if you go on the quiz, let me click on new quiz. I did it with the classic quiz. There's the same options. And I find the questions. Okay, I was in parametric questions. Let me just find these questions. Here we go, add questions. I just want to show you that the question is there. And I usually add the questions that say, please download your steps, so I can see their steps, so that I just don't grade them only on the final answer. I grade them only on the steps. So I click new questions, and I have the questions with a file, upload questions, and I say, please upload your steps. And let's say the first question is about 1 point. This one will be about 9. Update questions. And here is the quiz. Oops, doesn't matter. Save. I just want to show you what it looks like when now we click preview. We have a questions that is the question that we have, and we can see the value there that was randomized. So the wagon is released from rest altitude 33. Highest point of the blue B is at altitude 19. What is the velocity of the wagon B? And the students will enter. I need to add, make sure to include 1 decimal and give your answer in meter per second. I need to add that in that question. I will do it just after. And let's say I put 19.2, probably not the right answer. I upload the questions and I submit the quiz. And that will tell them if it's correct or not. So just my last little advice there, super important, of the wagon B includes what is the velocity of the wagon at B, include, so in meter per second, always specify units, include 1 decimal. If you don't write include 1 decimal, they will have something wrong. Oops, I will put it in bold. They have something wrong if they just put 0 decimal, because your margin is 0.1. And if they give, like, I don't know, 24 instead of 23.7, they will be away 0.3 instead. So they will not have the right answer. And update the questions. And here we go. So that's the questions. We add the bracket HA bracket HB. We enter the formula and we generate a random set of value, and Canvas find the VB for all those set of value. So I hope it was helpful. Let me know if you have any questions. Bye bye.